An important characteristic of membranes is going to be that they are selectively permeable, or that they have this characteristic of selective permeability. And what that means is that membranes are going to select what molecules or just substances, because this could be something like an ion. So they will select which ones get to cross. And this selection is going to change from time to time. So what gets across today may not be the same thing that's going to actually cross the membrane tomorrow. Now, although we do call membranes selectively permeable, there are some substances that do cross the membrane very readily, regardless of really whether the cell wants them inside or not. So again, for that, we need to think about the properties of the membrane. So remember that the inside of the membrane is going to be hydrophobic. We have lots of fatty acid tails, which have a non-polar characteristic to them. And then on the two outsides, we do have these hydrophilic head groups. Now, hydrophobic stuff only wants to be next to hydrophobic substances. So if you do have something like water molecules are going to be polar. And so they are not going to want to enter this hydrophobic area of the inside of the membrane. So they will really be excluded from there, and they will stay outside with the other water molecules or the hydrophilic head groups and that type of thing. However, if you do have molecules that do happen to have a non-polar arrangement to them, or if they have non-polar characteristics, they might enter that area very readily, especially if they're very small. So if you have something like oxygen gas, which is O2, this is a small molecule, and it can enter and it can basically pass right through the other side very easily because it is hydrophobic or it is nonpolar. So nonpolar substances, if they're small, they're going to cross very readily. And really for those types of molecules, the cell doesn't have much choice as far as whether they're going to get across or not. On the other hand, things that are not small, so large molecules, would definitely have a hard time getting across, and things that are not nonpolar are going to need help if we do want to get them into the cell. So for those types of things, so things that have charges, they're polar, or if they happen to be large, then we need help. So these would be the things that the cell is really specifically selecting whether or not they get to cross. And this is where a lot of the proteins that are embedded in the membrane are going to come into play. So the proteins, they will do this choosing. They will decide what molecules get to come across today, which ones do not, and again, they may change their mind tomorrow. Okay, so if we clean this picture up a little bit and we look at these proteins a little bit closer, we have two main types of proteins that are going to help molecules get across or participate in this selective characteristic. So these proteins as a group are called transport proteins. And these transport proteins do come in two different forms or two different types. And those two types are what we see on this particular picture. The first one over here is going to be what we would call a channel protein. And channel proteins provide essentially a channel or a tunnel that runs from one side of the membrane to the other. We do tend to think of these usually as being gated channels or gated proteins, and that means that they have kind of a little gate at one side where they can close that off or open it up so they can control whether things pass through or not. And for those channel proteins, the tunnel or the channel that they provide is usually going to be hydrophilic, because we don't really need a hydrophobic tunnel across the membrane because we already have a lot of hydrophobic portions on the inside of the membrane as it is. So the channel proteins, they will allow things that are small to flow right through, again, if the gate happens to be open. And these are going to be a little less selective because they do just provide a tunnel. They're not specifically binding anything. The second type of transport protein is going to be actually binding a molecule or a few molecules. So this second type over here is what we tend to think of as the carrier proteins. And the carrier proteins, they do have a site, and that site, I've drawn it right here, that is going to bind to a molecule or an ion. And once it binds that ion or molecule, the carrier protein is going to change shape in some way so that it actually transports that to the other side of the membrane. The carrier proteins are going to be more specific because they are actually binding to something, and they're going to work on really just one or a few different substrates. So again, the transport proteins, they are going to provide that selective capability of the membrane, and they will control what gets to go across, and they can change that from time to time.